I've been segmenting for about 4 or 5 years now, and I've done some fairly good-sized projects and a lot of smaller ones. Uh, yeah, a couple of months ago, I think it was probably July, August, somewhere in there. My friend here asked me if I could give him a little help with a project. It's the damnedest project I've ever gotten involved in. I never thought I'd be involved in a segmented wood turning project that would involve drywall screws, fiberglass, and plywood. But that's how we started. And behind me is the very beginning. I'm going to turn it over to Kelly now and have him explain what we're doing here.
Okay. Let's see this cleaner where I can put it. Okay, the piece we're talking about is actually the base for this is a diagram of a sculpture that I'm building for the Artisan Center. It goes to the Diversity and Inclusivity group over at the main campus, and they are called I Respect. So the little packs around that ring are cards, are pledge cards that people have signed, and they will be then cast in resin, a hole punched in the center, and that's all to be figured out how that's going to happen. But, so, this one, let's see, I'm trying to do this so you can hear me. When I called Jerry, I basically, all I had was the outside dimension of the bottom ring is what I wanted was 60, what do we go with? 64 inches at the outset. So when all the corners on the outside, the furthest point was 64 inches. So because I had no idea how to start this, so I went to somebody that knew about segmenting. And Jerry came up with a plan. Went to a computer program that set it up. There were 20 rings when we started, and it came up to be 15 inches high. In the end, that was 240 segments, 12 segments to each ring. I took off the very top segment, which was like a pie, and didn't use it. So there are 19, which would be 228 segments altogether, but that's them on an 8-foot table. So a lot of pieces. But as Jerry said, we had to do it on the floor of the shop because either that or build a table that was 5 foot square. So putting it together, my only regret was as I put the segments together, I used 1.25 inch drywall screws to pull each segment down. That was my clamp. There was no other way to clamp them all together. They were too short. They didn't have enough pull power. And that's the only thing I'd have done different was use at least a 2-inch screw that would have went through a couple of layers down and done a better job of clamping. So that's the rings. It was easier to do this whole project. I was doing it. I sat on the inside of it and worked. Otherwise, you're sitting on the outside on all those corners. So, and that, so, 3/4 of an inch. So it's I tried to use, I happen to have a lot of aspen on hand, and unfortunately not enough. I ended up having to go and buy more. Nope, 3/4 inch random width aspen. It's light. That my main concern was that this thing was going to get too heavy because there's some weight there. Once it all got together, a couple times it got the best of me. And
over 300 board feet, something in that neighborhood.
well, no, it came up to when just figuring the segments, it was 77 board feet, but there was a whole lot more waste so. But so going along, kind of working on, becomes a dome. getting to that point, you have nothing to register, so I just kept making it as close to being, within equal distance on what was sticking out at points. So after I got done, the first time I tipped it up, I could see, that's when I realized my screws to clamp the layers together weren't doing enough pulling power. So I tipped it up and I started pouring in epoxy resin anywhere I could see light through the cracks. And then I can do better than that, and I fiberglassed the whole inside. So I figured for strength, because on top of there, that as you looked at that sculpture, there's weight sitting on top of it. And I said to Jerry, what do you think? He says, well, I don't know how much that thing's gonna, well, how much it's gonna support. So I did this, so there's a dome underneath. But then at layers 12, 13, and 14, I put in a 3/4 inch deck. So that's 2 1/4 inches total that supports the sculpture from above, comes down and bolts to that deck underneath. And then the hollow cavity inside is filled with spray foam. So you could drive a truck on this thing now. I guarantee you it will not collapse. And but the first time I did it, I put the faceplate on the back of there, not knowing if it was centered, and I wanted to see how it all lined up. So I put it on, and then I backed it off of the spindle. It looked pretty good. Spun it and did all that. And I don't know what I was doing. I was down at the base of the crane. The piece is sitting on the sling I had for the gantry crane, and all of a sudden I saw movement. And it tipped out of the sling, and I just jumped back because I was down where the chain is at the bottom, and it kind of just rolled off, rolled against the brace of the crane and hit the floor, and I went, oh crap. I didn't even want to turn it over. I thought for sure this thing is done. There wasn't even a scratch in it. It took it like a champ. So yeah, exactly. It was tough. So at that point, it was turning it. And I think if you go on, Jerry, Mark Motquin came out and we knocked off the outside corners 5 hours straight with 4.5 inch grinders with carbide discs and stuff on it, knocking off the heavy corners. So as the whole shop was covered in a 1/2 inch of dust by the time we were done. It was as dirty as my shop's ever been. But then the turning, what surprised me with the turning of this piece is because of that large circumference, your forward motion takes forever. You're basically, it seems like you're just sitting still. So it just cuts so slowly, and that was the thing that surprised me more than anything else, was that it just turned, it was so slow. And of course, do we have the video on or no?
No, I couldn't put the video in.
Okay. It was fairly slow. Because if you stopped, and Mark and I did that the first time we turned it on, I stopped it, the brake on the lathe started to break, and the inertia from that big thing, it started to loosen up and started to wobble. It was close to coming off the spindle. I went, oh man. And I started to push against the piece so it would work, back onto the spindle, and I caught it before it came off. But yeah, it was almost a second time off the lathe. But so it came out. I don't know if you can tell from this picture, a little heavy to the top, and it's a little thinner down here. I think that's, and out here you can see it's a little thinner on those pieces. So it wasn't perfect center, but it was tolerable. It was in there, for out of round and getting the round piece out of it. But that's a VB36. It bolts to the floor. It's got a 2.5 inch spindle. Doesn't have bearings. It's got phosphor bronze, so it runs on a film of oil, and It's built for heavy duty turning, and that's why I made the gantry crane. I took a shop Harbor Freight gantry crane and put a smaller beam on it, so it's shorter. It just fits over the lathe, and that's how with that chain hoist I can go one click at a time. It makes it. You want to get in an argument with your wife, have her help you load something big on the lathe. You know, so I had to figure out a way of doing loading pieces onto the lathe by myself, and this is it. So. Yeah, so that is.
So how'd you cut the angles? Did you have a sled?
We did, and actually, Al and Al had put together that sled years ago in class, and it's been around, and we used it. And that, what was the type?
It's a wedgie sled.
Wedgie sled.
Yeah.
Yep.
Yeah.
So yeah, it was pushing it. The lengths were pushing that one to the limit. So.
Kind of a challenge with an 8-foot board trying to push it through.
Yeah. But
Kelly, did you glue up each ring and then glue the rings together, or did you?
started on the floor and glued up the first ring, had a strap clamp around it to pull it together, and I had to pick a ring that would fit my strap clamp even to start, because some of the rings my clamp wasn't even big enough for. But and then literally once, went from one ring, set it on top, and like I say, you're just hoping that by the angles fitting together that everything is fairly round, and it came out pretty well. So.
Kelly, when you applied the screws to it, where did you place the screws? Center of
So,
the board?
if you go, can you go back a few, Jerry?
I don't think I can. This only goes one direction.
So, but you didn't turn it?
So I would put 2 screws in each piece, and then towards the back edge, because I didn't want my screws to come out as I turned that front edge away, because the inside isn't turned. So I knew I could get screws in without them showing up to the outside of the piece. And next one, right there, you can see these. So I just, once the glue set up, I pop the screws out and go to the next ring. And so, yep. And that's what I was saying. I wish I had done longer screws just to get more power to pull down.
Yeah, I was wondering if you still had them in and you were turning.
I actually, this piece is now in back. I started finishing it, and it was a disaster. Went through about 5 layers of putting a dye into a waterborne finish, and it went very well. Right there, that's the black dye on without any finish in it. And then I started adding the dye to the waterborne finish, and I had an old bottle that had to be at least 10 years old. It went great, not a blemish in it. I ran out of dye, came to school here, got a bottle to add to waterborne, and something different. And it just had blemishes and blush that was beyond, and so I kept on, I put a couple coats of clear on to try to seal it out, thinking that it was contamination, because I had tried cleaning with acetone, denatured alcohol, water, nothing. Nothing to get rid of whatever this was doing it. So I went, okay, it's got to be the dye being added. So they changed the formulation of the dye or something. Got to the point of 10 coats on there. I'm not kidding when I say at least 30 hours into this finish. And so yesterday morning, I got the sander out and took it all off. Now it's in back with a new coat of black gloss with I went to the Minwax, the polyurethane with dye right in it, stain in it, but it's a solvent-based one. And now you can actually, I had built up so many coats on that first time that you couldn't even tell it was wood any longer. Literally, it was smooth as silk. It had a great feel, but, you know, it was, the blush just drove me crazy. All kinds of people said, oh, do this, do that. We tried buffing to see if it'd come out with this black stuff made for black paint, and nothing would get rid of it. There was always a little kind of that you could see it, or I couldn't, you know, live with it. But yeah, so it's actually back in the garage right now, waiting to get after the meeting today, I'll put a coat of clear over the black. But now it's back to being able to see wood grain in it again. So I'm happy with that at least. This thing will be 7.5 feet high, the base 5 feet wide. There's that hoop that goes on it is 68-inch diameter.
Any idea what the weight is, other than heavy?
Nope, no. A couple guys can pick it up though. It's still liftable. You wouldn't want to. You know, 3 of us moved it onto the trailer to get it here the other day, and without any problem at all. So.
Couple hundred pounds.
Oh yeah, yep.
So you turn the inside as well?
No, the inside's not turned, and that's where that fiberglass is, then that deck, and then foamed in the cavity inside of it. But no, I had, besides the incident on the lathe, I was working on it one day, because I would lean it against I got 2 sections of my shop and a door frame there, and it was up against the door frame, and all of a sudden I felt it hit my feet. And I went, okay. And I worked, and I tried to grab the back edge, and it pushed me back a little more. And I knew I was in trouble at that point. So I tried, as I'm getting further away from the top of it, each time I try to pull back to get the weight my way, it would push me backwards a little more. And I'm looking around, I'm in the middle of a doorway, nothing within reach, no phone in my pocket. And I'm going, oh, how long am I going to have to sit here before my wife, you know, she would have never come out and looked. So up above me, there was one of the 4-foot clamp for cutting wood. And I got it, I reached it, I got an intercom, and I hit the button on the intercom, and I said, get out here, I need help. So it was funny. She comes running out with her boots on the wrong feet, thinking that I was trapped under something or whatever. But she goes, yeah, I was. But yeah, what do you do? If I'd have moved, it would have hit the floor again with, you know, a half-finished surface. And I was worried about putting an indentation in it. And I can still see, even though I sanded it all out, I can still see a blemish that was up against where that door frame slid down on it. Even though, you know, so it's still, you know, it's amazing how that weight, you know, when it pushes in, leaves impression in the wood. So,
Kelly,
but
after the first ring, did you put individual segments around, or did you make a ring and then set it all?
I would do it with the strap clamp and set the segments on, put the strap clamp on to make sure everything looked good. I'd set it aside, glue everything, then put it back together on, you know, with the clamp on and screw it. And so I tried to, because it's like Jerry said, as long as you keep it concentric, it kind of works out, you know. So each ring, you get that kind of build up. But it was difficult because as I got going, it wasn't perfect. So all of a sudden you're doing measurements going, okay, so split the difference here, and you know, and so, but overall it kind of just worked out.
How thick would you say the wall ended up being?
Yep, at least 2 inches, yep.
And the boards were how wide?
Oh, some of them were 9 inches wide.
Yep. Some of the wides, yep, were, because you gotta remember at the top, especially, you were cutting almost straight across. So it was a real shallow, but then once you got over the curve, then you started getting more onto the edges of those. So, yep, those were the smallest discs were the widest ones.
Yeah.
So Kelly, when you're done with this, are you gonna turn a giant spool and use it for
Program. I had the privilege of being able to go to Turn On Chicago this past summer. And one of the featured demonstrators there was a guy named John Beaver. And Beaver is quite well known in a couple of circles. First of all, everybody here has seen a lot of Beaver's work. He's actually a professional photographer, and he's been the cinematographer, photographer on a number of motion pictures, TV shows. He does all kinds of advertising and stuff like that. And he's also quite an accomplished wood turner. He hasn't been wood turning that long, but he's developed a couple of very unique things, including something called a wave bowl. And the wave bowl is accomplished through a jig that Beaver developed. The jig is actually a jig that's used on a bandsaw, and the jig is designed so that you can cut essentially a perfect arc through a finished bowl to be able to separate it into 2, 3, 4, whatever number of segments you want. I've got my version of his jig here. If somebody wants to take a look at it after we're done, I'd be happy to explain a little bit more about what it does or how it works. This is the bowl that it's sitting over on the instant gallery table. This is my interpretation of Beaver's wave bowl. And the thing that's kind of unique about this, I looked around and I couldn't find any samples. And he told me that he's never done one out of segmented material. John's bowls that I found, and then when I spoke to him about it, are all done out of solid pieces of wood. And turning them out of a segmented bowl presents kind of a unique challenge, because in segmenting, you're dealing with miter joints that are end grain to end grain, and therefore are kind of weak. And then you have layers that are face grain to face grain. That's where actually a segmented piece gets its strength from. Well, in cutting the wave, you have to be careful about getting too much end grain to end grain contact, because it could make the wave weak and interfere with the ability to put the thing back together and hide the glue lines. The bowl starts out like pretty much any other segmented wood turning project. This is assembly. I use my lathe as a big clamp. There are all kinds of ways to clamp segmented rings together. I happen to like this process, where I've got the base of the bowl is mounted on a faceplate with a glue block on the headstock of the lathe, and then I just keep stacking them out. And I've got a series of center rings. These are actually high-density polyethylene rings. They're cone-shaped, so that I can pretty well center the piece as I'm assembling it and put enough pressure on it to get a good glue joint. There's one major exception, though, with this construction. Normally, you're not going to find a bowl this size. This bowl was somewhere in the 11 and a half inch range when I was assembling it. Normally, you wouldn't have walls that thick. These walls are about 2.5 inches thick. And you'll see in a minute the reason that I did it that way. The walls are oversized, which makes it for a very heavy turning blank. This probably weighed more than a solid chunk of wood would have weighed of the same dimension on the lathe. And what I did first was turn the outside diameter down to about 10.5 inches. At this point, the walls are a little over 2 inches thick. And one thing that's kind of different about segmented turning, if you haven't done it, if you've turned a bowl out of a solid chunk of wood, you're accustomed to the way the shavings come off and chips and stuff. Well, with segmented turning, you really don't have that much in the way of chips coming off. You get essentially a stringy material that's kind of like a big Brillo pad. Especially if your miter joints, your end grain to end grain joints, if the glue joints are good, you get a lot of this stuff hanging off the lathe, which actually makes it much easier to clean up the shop afterwards. Once I got the turning done to the outside diameter, I set up, I have something called a drill wizard. It's a one-way product that allows you to drill, essentially precision repeatable holes in turning projects. And this required 2 holes, 1 hole on each side. And those holes were just 1/4-inch holes, and they are designed so that you can recenter the bowl, realign it after it's been cut apart. I drill them near the inside diameter in what would anyway be waste wood and be turned away. So a lot of this is going to disappear pretty soon. We mount the turning blank on the jig, and the jig is set so that it has a pivot point here, and the pivot determines the arc that you're going to be able to cut your wave at. And you'll notice here, the 2 holes that are used for the dowels for registration. I use 1/4-inch dowels. And I drilled them a little bit off center so that when the bowl is being reassembled, you can get it back into registration. It'll only go together one way. The next step in the process is to align the saw blade to where you want the cut to begin. To take the top of the bowl off, the process is you take the top of the bowl off first, readjust your jig to cut the wave, and then cut the wave out, and that essentially winds up with a bowl that's broken down into multiple pieces. The saw is equipped, in this case, with a 1/4-inch fine-tooth blade. I used a 14 TPI blade, and I was really surprised at how smooth the cut I got with that. The cut was almost as if it had been sanded. Running your hand over it, you didn't get any of the rippling, the rough edge that you get with a normal bandsaw cut. But the downside to that is there are 2 things. First of all, you cannot stop the cut once it's in progress. If you do that, you're going to get a ridge that runs through the cut, and because these glue lines have to come back together as close to perfect as you can be, you don't want those ridges in there. And the other thing is that it's extremely slow. It takes a long time to make this cut, but it is what it is. After the top of the bowl was cut off, I repositioned the jig so that I could cut the wave portion out, and the wave portion in this case was a little bit under 5/8 of an inch thick, which is also the thickness of the wall on the bowl. At this point, it's actually in 5 pieces. You'll notice at the bottom there are 2 dowels that are laid out. And then you have the bottom of the bowl, the wave section, and the top are all separate sections. Now, here I'm differing considerably from the way that Beaver does it and other people. What he does is he takes veneer, and in some cases pretty thick veneers, and wraps it in a damp paper towel and heats it up in a microwave. And that is a way to bend wood. You can do it that way. But I was dealing with a pretty thick wave that wasn't going to bend anyway because it was segmented material. And to bend something that thick, I don't think it would work. I think the glue joints probably would ultimately separate or break the pieces apart. So I came up with another way to do it. I made fillers out of MDF, and MDF can be bent. If you get MDF wet enough and get it in a microwave, you can bend it. You can also set it on fire. So I decided not to do that. What I did instead is, going back to the days when I was playing around building furniture, I used a process that is referred to as kerfing, or kerf pieces. And all you do is you take a piece of MDF, or in a lot of cases plywood, and cut kerfs in it at 1/4 inch or 3/8 of inch intervals, depending on how sharp a curve you're going to do, and cut them a little bit more than halfway through the material. I think these are cut like 5/16 of an inch deep or something like that. And it does bend. and it springs back into shape, you know. But this is a process that's used an awful lot, especially in commercial office furniture, like a reception desk that have a curved front or something like that. They'll either use MDF or plywood for the substrate, bend it to, you know, the desired form, and then put a veneer over it, and you can't tell it from solid wood. So I decided to use 2 pieces of MDF, which are close to the thickness of the wave section, and I'll explain now why you want to do that. You reassemble the bowl without the wave in it, but the 2 filler pieces occupy about the same amount of space. And the reason that you want to do that is you're going to have to recut the profile on the bowl. Before I did any turning on it, I did depth holes. And I think the depth holes, again, were like 5/16 of an inch deep. And the only reason I did them is I wanted to know how deep I was going into the bowl, how much material I was taking off. So I can't see it from the inside because it's pressed together. The tailstock's got to be up tight against these things to compress them. So I drilled depth holes in it and turned down to get rid of the depth holes, and that would become the final dimension of the body of the bowl. And here's a shot of the bowl, turned down to final dimension, with these turned to the dimension that they are now. The fillers are in there to maintain the profile of the bowl, because if you just take the top section and the bottom section of the bowl and push them together and turn those, you're going to wind up with a really odd looking bowl, because they won't go back together right, because the profile is different. The diameters change with the curvature of the wave. So this is an easy way to maintain the profile of the bowl. And then the wave section itself, I masked it so that I would have wood grain contact with the glue. And I did an airbrush job on it. And the masking was to assure that I'd have grain contact for the glue. And I wanted to make sure that I had the outside portion of it at least covered, so that the inside portion covered, so I'd have the glue joints back together. And the mistake that I made on this, and I'm owning up to a couple of mistakes here that I made. First of all, I mentioned earlier that you don't stop the cut because it performs ridges. Well, I was working by myself and I wanted to take pictures of the project, so I thought, well, I'll take a chance on it. And you can see here where I stopped the cut. Should not have done that, because what it did is it made it very difficult to get the glue joint good and tight, because if you start sanding that out, you're removing material, and you have to remove it on both sides, not only on the wave portion itself, but also where it's glued into the top or the bottom of the bowl. So when you look at the bowl, pretend you didn't see that. And the other mistake that I made on this is that once I got the painting done, and this was airbrushed, what I should have done is I should have coated the painted portion with shellac, or probably a shellac, before I stripped off the masking material. The reason for that is, and some people may disagree with me on this, but I found it to be true, glue does not stick to shellac. It will dry on shellac and then adhere to it. But if you're gluing a piece together, if you have the opportunity to pre-finish portions that are close to a glue joint with shellac, what happens is when you put the glue together, of course, the joint together, you're going to get squeeze out. And squeeze out can be very difficult to remove on a naked wood surface. But if it's coated with shellac, it's very easy to remove. You just take, something, scrape it off, and then take a damp cloth and wipe it off, and it's not going to penetrate and it won't affect your final stain. Now, I should have shellacked this, and I didn't, and what it did then is when I put the glue joint together, it made cleaning this up a real project. And when I do another one of these, I won't make that same mistake again. Here's the wave portion, just ready to be glued on to the bottom of the bowl. You can see the two dowels, the registration pins.
Jerry, you had to cut the ring, cut the wave the same way you cut the bowl.
Absolutely. Yep. Yeah.
The ring was 4 pieces.
No, the ring was the entire circumference, but I never did actually count the number of pieces of wood in the ring. But this is a 16 segment ring, and each one of those each portion of the ring is at least 16 segments. But because it's cut at a curvature, you're getting portions of one ring, portions of the ring above it, and portions of the ring below it. So. And I just couldn't, once I got it put together, I couldn't resist spinning it on the lathe. I'm sorry, I thought I took a picture of it without the lathe running, but I didn't. The other thing that I discovered, and it didn't really affect me here too badly, but I can see instances where it would, is you don't try to glue the whole thing up at one time. If you try to glue it up at one time, you're going to have potentially some alignment problems. So the correct way, I guess, according to the guy that came up with this process, is to put the bottom on the bowl, glue the wave on, press it on with the top, wait till that dries, take it apart, and then glue the top on and press it together. That's actually the correct way to do it. And I'm using a big plywood disc that I use, to press segmented projects together, to put pressure on it to use it as a clamp. And from there, once it was glued together and the glue was dry, it came off the lathe. So I masked up the exterior because I didn't want any overspray, from my airbrush, and covered the bowl in plastic and did the inside of it. And put it back on the lathe. I gave it a coat of shellac. I've used shellac a lot more than lately than I ever have before, because it does make application of paints and of film finishes go a lot easier. You get a lot better finish, especially if you're looking for a high gloss finish. This thing only has 3 coats of finish on it. And normally, to get the kind of finish that I got on this, I probably would have put 6 or 7. So the shellac actually saved me quite a bit of finishing time. And there it is sitting on the workbench with the first coat of wipe-on poly going on. And parted it off, coated it with wipe-on poly, and there she is. One other problem that I had with this, I use glue blocks a lot, and I've kind of developed a liking for the Easy Wood Tools faceplate. It's an aluminum faceplate, and what I do with this is I'll put a glue block on the faceplate and true it up, and then mark point where the end of the screws are, and then put a second glue block on top of that and true it up. So when I glue the bowl or whatever project I'm working on to the glue block, I know how far back I can cut before I hit the screws, and that way the glue blocks are reusable. I only go through a couple of these every year or so. I've got 3 of them that are set up this way. And the mistake that I made with this one, I used soft maple for the first glue block. And then the second glue block on top of that was hard maple. So it was fine. What happened, though, was while I was turning this, I was hollowing the inside of it out. And I had just started to hollow the inside out. I was turning it about something in excess of 1,400 RPMs with a hollowing tool inside. And thank God I had my tool rest up inside the bowl. Otherwise, the damage would have been a lot worse, because I was getting, a lot of ka-chunk action on the inside of it, and I didn't realize that it was tearing the grain out on the soft maple. And bang, she came off the lathe and wrapped around the tool rest, caught my thumb, forefinger, and one of the fingers on this hand. And I thought, what the heck happened here? And I looked at it, and the glue joint itself was fine. but below that it ripped out the grain on soft maple. So, some people use softer hardwood, softwood. Some guys even use pine or construction lumber. I will never do that again. Anything that I do from now on is going to be hard maple, and it's going to be glued together, the way that I, should have glued this one, because to clean up the damage that did on that thing took a tremendous amount. I've got over 2 weeks in that bowl, and I think probably a good half of it was cleaning up the damage that I did from when it came off the lathe. And one side of me said, throw it in the fire pit and start over again. But I couldn't throw away a week's worth of work. So I took the time to clean it up and do the repair work on it. And hopefully when you look at it, you won't find too many of the problems. Yeah, Paul. Not really, but I had my hand on the bar, and when it came off, basically, my thumb was between the bar and the bowl, and that didn't feel good. And so, and I think what happened is it wrapped around. I think that's when it caught my forefinger. So, no, I always keep my hands on the right side of the tool rest, the back side, and pretty. Oh yeah, no, yeah, but I was, with my hollowing, I've got a Harrison simple hollower, and it's a very good hollowing system, because it's an articulating arm, so. That probably saved me a lot of grief. But I what I try to do is the vibration thing. I try to get the tool rest up as close as I can, regardless of what the shape of the piece is, to reduce the vibration. With this little Harrison system, I've actually gone as deep as about 9 or 9.5 inches, which is really stretching it. But if you're able to get the tool rest up inside the thing, that gives you a lot more stability for your cut. Yeah, Mark.
When you masked off the ring, did you put them all together, mark a line, or did you measure all the way around?
Yeah, the question was when I masked, did I assemble it and draw? Yeah, I did. I pressed it together, did a real light pencil line because I didn't want to have to do any sanding. Did a real light pencil line, then took it apart and cut the mask. So the mask is actually just a fraction of an inch inside the pencil line. So there's a little bit of overlap. There's a little paint under that glue line, but not very much. Anybody else? Thank you. And if anybody wants to look at the jig, this is it. It's my version of it is a little bit heavier than the version that the plan suggests. He likes to use 3/4 inch plywood, and I didn't have any 3/4 inch plywood, but I've got a ton of 1/2 inch Russian birch. And so I just laminated a couple of pieces together and got 1 inch plywood out of it. It made for a heavier jig, but I think it's also a more stable jig. And it has a number of adjustments. You can reset. This is the pivot point here, and the pivot point is what actually determines the arc that you're going to be cutting on. And then you reset the distance with a sliding track that slides back and forth on this. There's a piece of melamine under here that it slides on. And there is a commercial version of this jig. If anybody, first of all, the plans for it, I think he's charging $30 for the plans now. And what I will do, if there's enough interest in the club, I'll contact him and get his permission to put a copy of the printed plans in the club library. I'm sure he'll do that. If not, I'll just buy a set of plans for the club if anybody wants to mimic this thing. There is a commercial version of this available that has actually got more capabilities than this one has, but it's also like $400. So, and it is made out of plywood, by the way. So,
On cut A of the wave,
yeah.
does it have to be identical to cut B on the wave, or
No, it does not actually have to be identical.
aesthetically it would be nice if it was, but
Yeah, actually though, John's done some of his pieces with different pivots on the cut and you know a different shape of the wave.
cut one end, then
Yeah,
on the other end,
yeah, you can do that. Yeah,
just claim that's what you planned.
yeah, exactly. Yeah, yeah. All you have to do is reset the jig. The jig goes in the track on the bandsaw. It's got a bottom track here, and if you can see here on the bottom, these are the holes that adjust the pivot point. And so you set the bolt in here, you know, for wherever you want the pivot to be. And then once you've got that set, then you adjust the depth of the cut or the position of the cut with these two adjustable screws here. And the only reason he put two in here is for added stability. You could do one that is sliding on a track, but you know, after having played with this some, and I did cut some, you know, I turned just a real rough bowl out of construction lumber that I glued together and played with this a little bit to figure out, you know, how to set it and, you know, try to, you know, get a little bit ahead of the game before I did an actual project on it. You can adjust this to, you know, do whatever you want. The thing you need to do if you're going to change the thickness of the wave is you have to adjust it also in the slide. It's not, I don't think it's really that visible here, but there's a mark here on the base. This is where the gullet of your bandsaw blade needs to go if you're going to do you know, just a standard, you know, a typical wave. But if you're going to do an offset wave where you'd have it thin on one side and thick on the other, you'd have to adjust this one way or the other to be able to change the position of the beginning of the cut. That's how you change the thickness of the wave. I haven't really played much with that. I will one of these days, but you know, I just haven't had time to get around to it. Now, the other thing that I mentioned, you know, that I saw this at Turn On Chicago. Well, I walked through the demo room where he was about to do his demonstration and saw this jig on the bandsaw and couldn't figure out what the heck it was for. And unfortunately, I had another demo that I wanted to go to at the time that he was doing this one, so I didn't actually sit in on his demo at the symposium, which kind of put me at a disadvantage. But to his credit, this guy does answer his phone. And so I had the opportunity to spend some time on the phone with him, and he gave me a couple of little nuggets of information that he thought that he might not mention to the people in the symposium class. So, you know, maybe this is one of those cases by not going to the demo, I actually came out ahead. By the way, this jig is pretty much specific to your bandsaw, because there's no standard for the distance between the miter track and the saw blade. Same on table saws. So this might not work so well. Let's see. Oh. Okay. Yeah, this saw is there's quite a bit more distance between the miter track and my saw, but I can line this up pretty close here. Now I would clamp this in place, and by the time I get to this point, I would have the bowl mounted on the faceplate. And you start from this side with the blade not in contact but close to the point that you want, and you'd have to adjust the carriage back and forth so that you're getting to the point where you want the wave to start. And this would be the low side of the wave. So if you think about the wave going like this, you want it to start here as opposed to up here. And lock it down. And once it's locked down and secure, you also want to make sure that this is good and tight, because it is possible for this to turn. And you'll notice that the direction that it's turning here is also the same direction that the saw blade is traveling. So this has to be snugged down really good and tight, otherwise you have the potential for the saw blade to grab the bowl and turn it, and that will snap your blade, no question about it. So you tighten this down good and tight. Once everything is set to go, fire up the saw, and then just take your time and very slowly rotate it through. And you don't want to push the cut. You want to let the blade do the cutting, but you can't stop. And that's a mistake that I made on this one. I stopped a couple of times to take pictures, and I shouldn't have. But you glide all the way through, and then obviously catch the piece that comes off so that it doesn't hit the floor and ding up your work.
So you actually don't slide the jig.
Right.
It's all turning.
Yeah. Yeah. Now there is an application for this where you do slide the jig, but once you've got the top cut off, you want to readjust it for the wave. So you just slide the carriage in this case, you slide the carriage back the distance that you for the thickness of the wave, lock it down again. Go. Now, I discovered this kind of by accident. Anybody ever? How many of you use glue blocks on bowls? Okay. Ever had any concerns about what's happening when you're parting that glue block off and you got that bowl that's going to maybe come flying off your lathe? This is the answer, man. All you do is you immobilize this by putting another bowl here so it doesn't pivot. Take this over to your bandsaw, line it up, start the bandsaw up, and just slide it through right on the glue block. Your glue block is gone, your bowl's separated, and nothing came flying off the lathe at you. So I will get some more use out of this jig other than just doing waves. So.
So if you wanted to make just an angled ring, a straight ring, so then you would set your angle and push the tool through, right?
You could, yes, absolutely, yeah.
Like a Saturn ring.
Yeah, it'd be easy to do. That's where the commercial version of this, where they've taken that into account. They structured the way the carriage attaches to the base plate a little bit different. It has miter tracks cut into it with knobs that you can lock down so that you can pivot it to some position that you want, some angle, some degree, and then lock it down and slide it through. That's one of a number of things that they've done. I just couldn't see spending $400 for a jig. Any other questions? Okay. Thank you.